Hello to everyone. In this video we are going to be solving a very interesting integral, which is that integral that has been displayed to you. So I would like each and everyone to pay kind attention and follow up. If you have any questions at the end, you post your questions on the comment section and I'm going to reply to it. So this is the integral that we have on board and we want to find its exact value provided it converges. So before we begin with this integral, I will first of all present to you guys some basic recalls where we are going to use to dissolve the integrand into a good function that we can integrate. Alright, so the first recall is our basic laws of indices. The n root of x is simply x raised to the power 1 on n, and we all know that we are in the set of real numbers, so x should be greater or equal to 0. So by so doing, we can get the square root of x to be equal to x raised to the power half. The cube root of x is equal to x raised to the power 1/3, and so on and so forth. Now the second thing is now here we have the n root of x times the m root of x. So we can clearly see here that here is what we are looking for, the n root. We are looking for the n root of x times the m root of x. So by so doing, we can separate this into, we can rewrite it as the n root of x times x raised to the power 1 on m, because the m root of x is simply x raised to the power 1 on m as per our first definition. So by so doing, we can separate this as the n root of x times the n root of x raised to the power 1 on m. So with that, we get the n root of x is simply x raised to the power 1 on n, which is this, times now the n root of x raised to the power 1 on m is simply x raised to the power 1 on n times 1 on m. So applying the several laws of indices, the addition, we have x raised to the power 1 on m plus 1 on m times n. Okay, so with that, let's see how we can dissolve or simplify our integrand to get something that we can easily integrate. So that is the integrand. So using the first and the second recalls that I have given, we can get this integrand to be simply, now this t remains here. Now here is a square root of t times the cube root of t, the fourth root, and so on and so forth. So simply we are going to get, taking the first t here that is inside the square root, we just have the square root of t. Now if we take this next t here, which is inside the cube root, we are going to have the square root of that cube root, and so on and so forth. We are going to use this law and then we obtain this. So by so doing, we have t, which is this, times the square root of t, which is t raised to the power half, times the square root of the cube root of t, which is t raised to the power 1 on 2 times 3, times the square root of the cube root of the fourth root of t, which is this, and so on and so forth. Now it means that our integrand is simply equal to, we now use this law, we have t raised to the power, for better understanding, I will write t as t raised to the power 1 divided by 1, so that we are going to see the trend happening here and we can easily identify what the sum is going to yield. Alright, so the first power of t is 1, the second power is 1 over 2, the third power is 1 over 2 times 3. We can still write times 1 because you see here the same thing. The third power is 1 over 4 times 3 times 2 times 1, and so on and so forth. So with that, we get 1 over 1 factorial, because we can identify the denominators as n factorial. 1 over 1 factorial, 1 over 2 factorial, 1 over 3 factorial, 1 over 4 factorial, and so on and so forth. Now we need to identify what this sum is going to yield. So we are trying to look for what the sum 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial and so on and so forth is going to yield. Simply, we can write it using the summation symbol as the sum from n equal to 1 to positive infinity of 1 over n factorial, as you can see. So if we consider the Taylor series expansion of the exponential function of x, which is e raised to the power x, we simply get 1 plus x squared on 2 factorial, the infinite sum. Rewriting it in the summation form, we get the sum from n equal to 0. Remember, n is beginning from 0 and I have highlighted it in white. So the sum from n equal to 0 to positive infinity of x to the n on n factorial, that is a closed form of this infinite sum. So if x is equal to 1, because comparing this closed form of the sum with this closed sum of this sum, we see that for this to be equal to this, then simply we have replaced x with 1, because 1 to the n is still 1 and the n factorial remains. So for x equal to 1, we get simply that e raised to the power 1, which is this infinite sum, can be written in this form. But now what are we looking for? We are looking for this sum, which is 1 plus 2, that is this sum 1 plus 2 plus 1 plus 1 on 2 factorial plus 1 on 3 factorial and so on, which is equivalent to this sum. So from there, how can we get it? We are now summing from n equal to 1 right up to infinity, which is what we are looking for. According to this guy here, we can get it as simply taking e minus 1. So from there we get our sum as e minus 1, because from here, that is 1 plus 1 on 2 factorial is simply what we are looking for. So 1 plus 1 on 2 factorial plus 1 on 3 factorial and so on is simply equal to e minus 1. Alright, so we have gotten this as t raised to the power e minus 1. By so doing, we can get the integral, which is the integral from 0 to 1 of our integrand, to be simply the integral from 0 to 1 of t raised to the power e minus 1 dt. Alright, we now recall from the fundamental theorem of calculus. If we are integrating to t to the n dt, where n is a constant and t is our variable, we are just going to get t raised to the power n plus 1 divided by n plus 1 plus k, where k is a constant of integration. It should be noted that n is different from negative 1, because if n is equal to negative 1, then the result will not exist. Moreover, if you integrate t raised to the power negative 1, it's equivalent to integrating 1 over t, which is standard as the Napierian logarithm of the absolute value of t. Now we add a constant of integration because it is an indefinite integral. If it was a definite integral, we just fit our limits and we get the numerical answer. So from here, our integral is simply equal to the integral from 0 to 1 of t to the e minus 1. Following this, we add 1 to the power and we divide by the power plus 1 as well, and it is a definite integral, so we have our limits of integration. Alright, so from there we get our integral to be integral, which is t to the e divided by e, because negative 1 plus 1 is 0, negative 1 plus 1 is 0. Now it's a definite integral, so we include our limits of integration. Now when we fit our upper limit, we get 1 to the e over e, which is simply 1 over e. When we fit the lower limit, we simply get 0. So from there we get this integral to be equal to 1 divided by e. So that was that for the video. You can email me on my email address, which is being displayed to your screen, to propose interesting mathematics problems, and I'm going to see how to produce a concise solution to it and do a video and upload.